Hello and welcome to this R tutorial. So in the previous tutorials we made our first two steps of building our polynomial regression model, which were to pre-process the data, and actually that was really simple because we just needed to import the data set and select the columns of interest. And then we fitted two models to our data set, the linear regression model and the polynomial regression model. So we built the linear regression model as a reference of comparison of the polynomial regression model that we also built. And speaking of comparison, in this tutorial we are going to visualize the graphic results of these two models, and therefore we're going to make two plots here, one plot for each model where we're going to see the real observations and the predictions. And it's in this tutorial that you're going to be convinced of how more powerful the polynomial regression model is compared to the linear regression one. So right now, let's write the code to visualize those results. So we're going to do this with ggplot2. In case you didn't follow the linear regression tutorials on R, I'm just going to write the line to install the ggplot2 package. I'm not going to install it, but it's just in case you don't have it. And to check that, you need to go to the packages here and check if you have the ggplot2 package here. And so if you don't find it in this list here, you need to install it. And to install it, it's really simple. You just need to type here install.packages. You can press enter here. And then in quotes, you enter the name of the package, which is ggplot2. And then you just need to select this line and execute this line by pressing Command or Control plus enter. And this will install the ggplot2 package without any issue. I'm not going to do it because mine is already installed, but you can trust me, it will work perfectly. So I'm going to put that as comment by pressing Command Shift plus C. All right. And now we can start to visualize the linear regression results. So as you can see in the packages here, the ggplot2 package is not selected here. So I'm going to need to select here. So either I can click here, or the better way is to automate the selection of this package thanks to the script. And to do this, we just need to add the line library and in parentheses the name of the package with no quotes. So just ggplot2 here, this way. And when this line will be executed, actually we can check it right now. As you can see, ggplot2 is not selected. I'm executing this line and now it's selected. Okay, so now that our ggplot2 library is selected, let's start building the plot. So we're going to do exactly like in simple linear regression. We're going to use the ggplot function, and then we're going to add the different components in the graph. So first we will add the real observation points thanks to the geomPoint function, and then we're going to add the predictions component thanks to the geomLine function. Then we're going to add a title to the plot thanks to ggtitle, and then a label to the x-axis with xlab, and a label to the y-axis with ylab. So very simple, exactly like before. We're going to make this graph step by step. Okay, so let's start with the first step. The first step is just to type here ggplot with parentheses, and that will initiate the plot. And now remember, we need to add a plus here, and that's where we start to add the different components. So the first component is the real observation points, and we are plotting them with the geomPoint function. So let's add here geomPoint, geom_point actually. Here it is. And now we input the arguments in the parentheses. Okay, so the first argument, remember, is the aesthetic function. So that's in this function that we will input the x coordinates of our observation points as well as the y coordinates. So let's do this. AES for aesthetics function. So in this aesthetic function, we need to input the x coordinates and the y coordinates of all our 10 observation points. So let's see what these coordinates are. Let's have a look at our data set. So our 10 observation points are characterized by their levels and their salaries. The x coordinates corresponds to the independent variable that is the level column here. And our y coordinates will be our 10 salaries here associated to these 10 levels here. So in short, the x coordinates are the independent variable values that is the 10 levels here, and the y coordinates are the dependent variable values, that is the 10 salaries here. Okay, so let's input that. So x here is level and y is salary. However, since we did not specify that the data is data set here, our data set, we need to specify where we are taking the levels and the salaries. And to specify that, we need to add here dataset $, so that R understands that we are taking the levels of our dataset here. So it's going to be the same for Y. We're going to specify that we're taking the salaries of the column salary in our dataset. This way. Perfect. And now we can add another argument, because this aesthetic function was the first argument of this geoPoint function. And remember, we can add a second argument, which we will add because we want to add a color to our points to then make the distinction between the real observation points and the predictions. And so we're going to pick the red color. So here I'm going to add the color argument and set it equal to red in quotes. All right, and now let's not forget to close the parenthesis of the geoPoint function, because this parenthesis was for the aesthetic function. And now we are all fine. Great, and now let's add the second component, which are the predictions. So I'm going to add a plus here and add my second component here. So the second component is, as I just said, the predictions, and we're going to add these predictions component with the geomLine function. So exactly like we did in simple linear regression. So geomLine here, geom underscore line, and then parenthesis, of course. And again, we're going to take the aesthetic function combined to a color. So I'm just going to copy all this, right, and paste it in my geomLine function. All right, and now, of course, we will change a few things. So first, let's start with the simplest. Let's change the color. We're going to pick a blue color for our predictions. Here we go. And now what we need to change are the coordinates of our prediction points. So the x coordinates of our prediction points are still going to be the levels themselves, because we're just predicting the salaries of the 10 levels that we have in our data set. So here we obviously need to take the only levels that we have in our data set. So we keep here dataset $level. But then for the y coordinate, of course, something is going to change here, because by taking dataset $salary here, we're taking the real salaries of our 10 levels. That is the salaries that are in the salary column of our dataset here. So, of course, we need to remove this and replace it by something else. And what is this something else going to be? Well, of course, it's going to be the predictions of the salaries of the 10 levels according to the linear regression model. And to get these predictions, we're going to use, of course, the predict function. And so actually, that's exactly the same as in simple linear regression. In this predict function, we first need to specify the regressor. So the regressor is called linreg, because we're plotting the linear regression results, and our linear regression model was called linreg. That's our regressor, so linreg here. And now the second argument, remember, is new data. So new data here, and that's actually the data points we want to make predictions on. So very simply, that's our data set, because we want to get the predictions of the salaries of the 10 levels of our data set. So here we input indeed data set. There, perfect. So we're good, because we already inputted the blue color for our predictions. Great. And now let's complete this graph very quickly by adding a title, so plus here, and then we use the ggtitle function to add a title. Can you see how it's simple? It's starting to get really intuitive now. We were plotting the real observation points with the geoPoint function, then the predictions with the geomLine function, and now a title with the ggtitle function. Well, everything will seem easier and easier for you. So for the title, we're going to add, as in Python, truth or bluff just to give a funny name to our problem. And we're going to specify here that we are plotting the linear regression results. So we will just specify here linear regression. All right, so that's it for the title. And now let's add an X label and a Y label. So for the X label, we're going to add simply here xlab, parenthesis, then quotes, and then level, because our x-axis will contain the levels, and then plus ylab, parenthesis, quotes, and salary. And done! The linear regression results are ready to be plotted. So let's not wait anymore, and let's immediately have a look. So I'm going to select all this. I don't need to select this because ggplot2 is already imported. And now let's press Command or Control plus Enter to execute. And here are the linear regression results. So let's zoom on it and let's interpret. Great. Okay, so what is the first thing to understand here? Well, the most important thing to understand is definitely that we need to make the distinction between the real observation points, that are the red points here. Each point corresponds to one specific level and the real salary associated to this level on the y-axis here. And then we have our predictions on this line. That is that for each level, let's take for example the level 5. When we project this level 5 here on this straight line here, this point is actually our prediction point, and we can get the predicted salary by projecting this point here on the y-axis this way. And so we get a little less than $250,000. Okay, so that's the first thing to understand. The red points are the real observation points, and the points on this blue straight line are the prediction points. Okay, now the second important thing to understand is that our prediction result is actually a straight line. And the fact that it's a straight line is due to a particular reason. It's that the linear regression model is obviously a linear model. Each time you build a linear model in 2 dimensions, you'll get a straight line. And I'm highlighting this because the next model we're going to visualize the results is going to be the polynomial regression model. And this model turns out to be a nonlinear regression model. And you will see that it will not be a straight line anymore. And now let's give some interpretation. So first of all, we can see that this linear regression model represented by this blue straight line here is not fitting our data set very well. Because as you can see, for some observation points, the prediction is actually pretty far from the real observation. That's the case for this point, and same for this point as well, and this point, and especially this point. Let's have a look at this point, for example. Well, this point is the real observation point. It corresponds to a 10 level and a $1 million salary. So it's definitely the salary of the CEO, and so that's the real salary. And now if we want to get the predicted salary for this particular observation points that represents the CEO, what we need to do is project this point on this blue straight line here, that is our linear regression model, to get actually the prediction point. And now to get the predicted salary of the CEO, we need to project again this prediction point onto the y-axis that contains all the salaries. And so we obtain that the predicted salary of the CEO is actually $620,000 according to our linear regression model. So imagine we're negotiating with a future employee that is about to be hired, and that was the CEO in its previous company. Imagine how furious this person will be if we tell this person that we believe it's bluffing because we think its salary is around $600,000, whereas its previous salary was in reality $1 million. The negotiation would probably turn really bad. So that's the first example of how this model can give poor results that can have a very negative impact on the situation, like the negotiation we are having right now. So let's see if the negotiation would actually turn bad for our real situation, that is this future employee that is about to be hired and that has a 6.5 level and that is negotiating its salary by saying that its previous salary in the previous company was 160K. Well, let's see. The 6.5 level corresponds to this level nearly. And when we project this level to our regression model, that is this blue straight line here, and if we project again this point on the salary axis, we get a predicted salary of, well, it's more than $300,000 definitely, so actually we're way above what this employee said its previous salary was. So actually in this situation, in our real situation, the negotiation would turn well for us. But still, we want to get the accurate prediction, and clearly to do so we need to improve the model and make a nonlinear model which will fit much better the observation points here. That is, that we will make some kind of a curve that will approach much better all the red observation points here. So let's do this. Let's close the linear regression results and let's start to visualize the polynomial regression results. And you're going to see now how easy it is to go from the linear regression results to the polynomial regression results, because what we will simply do here is, select this and paste it here, and now you will see how we only need to change very few things. So as usual, let's start with the simplest. Let's replace linear here by polynomial. Okay, and now what do we need to change? Okay, so do we need to change something in the geom point function? No, of course, because we want to keep the same real observations, so that's okay. And then do we need to change something in the geom line function? Of course, yes, because here we are predicting the salaries of our 10 levels in our data set according to our linear regression model. So according to you, what do we need to change here? Very simply, well, actually we just need to change the regressor in the predict function, and instead of taking the linreg, which is the linear regressor, we're going to take the polynomial regressor that we called polyreg. And that's it. That's actually all we need to do to visualize the polynomial regression results. And you will see that in the next sections, it will actually be the same. We will only need to change the regressor to plot the new graphic results of our future regressors. So that's very nice. We're actually ready right now to visualize the polynomial results. So let's do this without waiting. I'm going to select this and press Command and Control plus Enter to execute. And here it is. As you can see, this is not a straight line anymore. Let's zoom on the graph. All right. So as I just mentioned, the first reflex to have as a machine learning scientist is that this is not a linear model anymore. And by the way, congratulations, you just made your very first nonlinear model. We're going to see plenty of other nonlinear models in this course, but this is your first one, so congratulations. So as you can see, it's not a straight line, now it's a curve, and we can immediately see that the curve is approaching much better all the red observation points. And especially for the CEO here. The CEO wouldn't get mad now if we negotiated with him its future salary in a new company, because now the prediction is much closer to the real observation point. And let's check our employee that is about to be hired and that has a 6.5 level. Well, 6.5 is around here. And when we project 6.5 on our polynomial regression model represented by this blue curve here, we get a predicted salary. Here I'm projecting the point on the curve back again on the salary axis, and we get actually a salary that is coming much closer to the salary mentioned by this future employee, which is around 160K here. Well, we don't get the accurate prediction yet because that's what we're going to do in the next tutorial, but definitely this model is fitting much better the dataset. And now, just for fun, let's add a new degree to see how this model can still be much improved and almost passing by all the points very accurately as we add more degrees. So let's check it out. Let's close this and let's add a new degree. So very simply, what we're going to do is add a new degree here by copying this line, paste it here, and we're going to add a new column in our data set, level 4 that will correspond to our original independent variable level at the power of 4. And so therefore here we need to compute it this way by taking the 4th power of level there. And now let's execute this line to add the level 4 column in our data set. Now you can check to see that it's here, level 4, perfect. And now let's reselect this to rebuild our new polynomial regression model with this 4th degree now. So executing, new polynomial regression model created. And now let's have a look at the results. So these are the previous results corresponding to a polynomial regression model with a 3rd degree. And now let's look at what happens with a 4th degree. So I'm going to select this and execute, and here are the polynomial regression results for a polynomial regression model with a 4th degree. Okay, so as you can see, we can zoom on it if you want. As you can see, the line is actually strictly passing by all the red observation points, and now the CEO would be even happier with the negotiation, or should I say even less furious, because the prediction now is actually almost the same as the real observation point. That is, the predicted salary is almost the same as the real salary. Okay, and same for our 6.5 level employee. When we project this 6.5 level here on the curve and then project it again on the y-axis, that is the salary axis, we get a value around what he said, that is 160K. And for those of you who are interested in having a more continuous curve here like we did in Python, I will add the code for that job in the R file provided in this section. You can check it out for fun. And this is the model we're going to use to get the accurate prediction of the previous salary of this new employee that is about to be hired. And we will compare it to the salary that it pretended to have in its previous company and eventually tell our final verdict whether it's truth or bluff. So I look forward to doing that with you in the next tutorial.